Question number 11. AB is a uniform rod of length 80 centimeters and weight 24 kilogram weight. The end A is attached to a hinge fixed on a vertical wall, and the end B is tied by a light string of length 80 root 3 centimeters fixed at a point C on the wall, which lies directly above A and at a distance 80 centimeters. If the rod is in equilibrium, find the magnitude of the tension and the reaction of the hinge. First, we'll draw a figure to represent the question. Solution. Here we have the wall, and we have the end A here of the rod, and we'll draw the rod like this. Its length is 80 centimeters, and we have another point. The rod, of course, is AB. Here is AB, and we have another point C directly above A, such that the length of the string BC equals 80 root 3. 80 root 3. So we write some information. The length of AC is 80 centimeters, and the length of AB is 80 centimeters. The rod is uniform, so its weight acts on its midpoint like this, and we write 24 kilogram weight. If the rod is in equilibrium, and don't forget that the length of CB is 80 root 3 centimeters, the reaction of the hinge, it is unknown its direction. Its direction is unknown. So we expand the line of action of the weight like this, and the tension in the string will be in this direction. The reaction of the ring must pass through the point of intersection of the weight and the tension. So we must draw it like this, and here is its direction. The triangle ACD, I'll put another point here, is D, like this. This point is D. So the triangle ADC is the triangle of forces, such that the direction of R passing through the point D, and here we have the direction of T, and we represent the force 24 in this direction. It's parallel to the weight. So now we must calculate the length of all sides of the triangle ACD. We have AC equals 80. AC equals 80 centimeters. And now we want to calculate the length of CD. So we say, since CA is parallel to, let us make a point here, is DE, and E is the midpoint of AB. So we can deduce that D also is the midpoint of BC, of line segment BC. So CD equals 80 root 3 divide 2, which equal 40 root 3. So here is the length of CD also equals 40 root 3. Now we have AD is perpendicular to CB because triangle ABC is isosceles triangle, such as that's because AC equals the length of AB and D is the midpoint of BC. So we can say that measure of angle ADC equals 90 degrees. So what is the length of AD? AD using Pythagoras theorem equals square root of AC square minus CD square, because AC, it is the hypotenuse of triangle ADC. It's opposite to the angle of measure 90. It is opposite to angle of measure 90. So AC is the hypotenuse, and we complete calculation. AC square, it is 80 power 2 minus CD square, which equal 40 root 3 power 2. Now we will calculate the length of AD equals the square root of 80 square so the length of AD equals 40 centimeters, and the length of DC equals 40 root 3, and the AC equals 80 centimeters. Now applying triangular forces rule, we have 24 over 80 equals R over 40 equals T. It's the tension over 40 root 3. 40 root 3 is the length of CD. It means R equals 40 multiply 24 over 80, and you calculate it, equals 12 kilogram weight. And also we will calculate T. T equals, here cross multiplication, here we calculate T equals 24 multiply 40 root 3 over 80. Divide 40 equals root 3. Divide 40 equals 2. Divide 2 equals 1. Divide 2 equals 12. So the tension equals 12 root 3 kilogram weight.